flip up the first flap. This is important information, or important vocabulary. Some of you guys, it might be hard to read that first word just because of the way I stapled it. I do apologize for that. Now, surface area is the sum of the areas of all of the faces of a 3D figure. Alright, so it's kind of like an irregular shape, so you have to find the sum of all the areas, and then you have to add them all up. Keyword there is sum. What does sum mean? Alex. Thumbs up when you're ready. All right, the net is a 2D representation of a 3D figure. And it'll make a little bit more sense when we get into this foldable. But nets are usually the way that we try to, it's one of the ways that you can try to solve for a 3D figure. And then a prism is a polyhedron that has two parallel identical bases and is connected by parallelograms. All right, stand up when you were done with this. A 3D shape. That's what they call 3D shapes or polyhedrons. So a polyhedron is a 3D figure. BK, back up a little bit so they can see around you. Just stand on like the other side of your thing. All right, go ahead and flip up your flap. And we are on surface area of a rectangular prism. So a rectangular prism has 6 rectangular sides. It has 3 pairs of identical faces. And then to find the surface area, you can find the area of each side and, bless you, add them together. So to find surface area, you find the area of each side and add them together. Now, each side is what? What shape? It's a rectangle. So each side of your rectangular prism, what is the formula you are going to be using to find that area? So A equals length times width. That is the formula you're using for each one of the sides in a rectangular prism. Now, I am going to write the formula, but you will never see me use the formula. The reason I'm writing the formula is because in the future classes, in 7th, 8th, 9th, and so on, you will see this formula. You will never see me outright do the formula though. Okay, so the formula is 2 times length times width times 2 times length times height times 2 times width times height. Now, it is very important for you to know the surface area is still measured in square units. How? How do you think the surface area, or why do you think the surface area is still only square units when we're dealing with a 3D shape? Right, and you're only multiplying 2 numbers per side. You're multiplying length times width, so you're only multiplying 2 numbers per side. You add up all of the sides, but you're not multiplying all of the sides. When we find volume, you do length times width times height. That is why it's cubed, or to the 3rd power, or whatever you want to call it. But with surface area, you're still only multiplying 2 numbers to find it. All right, thumbs up when you're ready to move on. Christian, are you ready? All right. So we are going to find the surface area of this rectangular prism. Now, before we get started, let's look at the shape. What do you notice about the shape? And this is a net. So this is the 2D version of a rectangular prism. So what do you notice, Christian? They are all rectangles. We literally just said a rectangular prism is made up of 6 rectangles. So they are all rectangles. Okay? What else do you notice? That
multiple faces and it's multiple measurements.
Say that one more time.
It's cut into multiple rectangles and it has multiple measurements.
Okay, so there's lots of different measurements on this shape, and it's cut into multiple different rectangles. All right, what do you notice about the rectangles, though? What do you notice? Look a little bit closer. What do you notice about some of those rectangles? Silas? Are all of them different sizes? No. Some of them are different sizes, but not all of them. Okay? What do you notice, Alex?
That there's some of the same shapes.
What do you mean there's some of the same shapes?
There's a rectangle on top and the one below the one underneath it is the exact same size as that.
So you're saying this one and this one are the same size?
No, the one underneath is one below.
So the third one. Yes. Okay.
So I'm saying like these two are identical and these two are identical.
And what about these two?
Yeah.
Okay, and that's where the times 2 comes in. So the formula of times 2 times length times height, because essentially you only have to find the area of 1, 2, 3 rectangles, and you can multiply it by 2. There are a couple different ways that you can go about identifying this. I use a lot of colors or numbers or letters. Sorry, not numbers. I use letters. The reason I use letters is because there's already how many numbers on here? A lot. So if I put another number in there, it would confuse us. So I'm going to label this A and this A in orange. Okay? I'm going to write A over there. And I'm going to circle it because I don't want to get confused and say, well, that's area. No. All right? Now, somebody raise your hand and tell me another set of rectangles that are the same. Okay. The bottom one and the middle one. So we're going to do B and B. And then the last one is obviously this one and this one. And I'm going to label that C. All right, I want you to cover everything up except for this top rectangle. Whoever is whistling or making a noise, please stop. So in the top rectangle, do you see 2 numbers that are going to give me my length and my width? Okay? Now, I did cover up this 4 right here just because I don't want us to get confused, but hopefully we don't get confused with that 4 because it's kind of off to the side. So what 2 numbers are we multiplying together to find the area of that rectangle? Gracie. So I'm going to do 5 times 4. And then raise your hand and tell me what is 5 times 4. Gracie. No. No. Okay, so this is 20 centimeters squared. So if that one is 20 centimeters squared, guys, what other one is 20 centimeters squared? Okay. Yeah, the other A. So I don't have to do any other work for that one because I know both of those are the same. Does that make sense so far? All right, B. So B is this one. Now, right now, if I covered everything up, do I see any numbers for B? No. All right, so let me go down here. Do I see any numbers for B?
Yes.
All right, raise your hand and tell me what are the 2 numbers I'm going to be multiplying by. Kira. And what is the answer for 5 times 2? Kira. All right, so this is 10 centimeters squared, which means this is going to be 10 centimeters squared. All right, and then the last shape, I'm going to cover everything up. And what 2 numbers am I multiplying together to get the area of this one? Silas, what is 4 times 2? All right, so right now, we have a whole lot of numbers in here. So what can we do? What's one thing that we can do to find the surface area of this shape? Silas? You can add them all together. All right, another thing you can do is you can multiply this by 2 and get 40 centimeters squared. You can multiply this by 2 and get 20 centimeters squared. And you can multiply this by 2 and get 16 centimeters squared. And add those together. You can add 20, 10, 8, and multiply that by 2. There are so many different ways. So I want you to figure out if you're going to do it this way and find the total, if you're going to do it this way and then multiply that by 2, or if you're simply going to add those up. Whichever way you decide, you need to show your work. Okay, stand up when you have your answer. right, have a seat. So how many of you guys just added 40 plus 20 plus 16? Okay, Silas, what'd you get?
76
No.
centimeters.
Yes. All right. How many of you guys did 20 plus 10 plus 8 times 2? Okay, well, what is 20 plus 10 plus 8? Samantha.
38.
And then 38 times 2 gives me 76 centimeters squared. All right, how many of you guys added 20 plus 20 plus 10 plus 10 plus 8 plus 8? Okay, Joshua, what'd you get? All right, so no matter which way you did it, your answer is surface area equals 76 centimeters squared. Okay? That is how you find surface area of a rectangular prism. It's not too hard. Okay? When it gets hard is when you have decimals. When it gets hard is when they don't make it as easy to find the numbers for each shape. All right, any questions about this one? How do you guys feel? Why are you half? I'm not talking to you. Why are you half? Like, what was hard about it? Did you cover up each shape? All right. And guys, I know it seems so elementary, but if you go through and you cover up each shape, you're always looking for the two numbers that correlate to what you're looking for to find the area of that shape. So you're looking for the length and the width. So even if you do not want to, until you get comfortable doing this, I highly recommend it. You can do it on your iPad. You can do it with any of the other shapes that you're going to come across. All right. Triangular prisms. Very similar to rectangular prisms. The biggest difference is that it has two triangles in it. So a triangular prism has 5 faces. Two of the faces are identical triangles. So if they're identical triangles and we're finding surface area, which means we have to find the area, what do we know about both of those triangles? They're going to what? If they're identical, they're going to have what? BK? Yes. So underneath this, kind of small, right? Same area. Okay? That's going to be important. The other 3 faces are parallelograms. And you guys do realize a parallelogram can be a rectangle, right? Have you guys figured that out? Okay, if you have not, draw an arrow and write can be rectangles. And then it says you can use a net to help you find the surface area. Bless you. And then to find the area of each shape, then add them together, and the surface area is measured in what kind of units? What kind of units is surface area measured in? What kind of units did we just write? No, that's not. No. Samantha?
Square.
Yes. Thumbs up when you're ready to move on. Thumbs up when you're ready to move on, y'all. All right. Now, we are going to find the surface area of this triangular prism. Before we get started, what do you notice? What do you notice about this shape? Tell me some things. Gabe, what's one thing you notice? Okay, so Gabe says there's 2 equal triangles and there's 3 equal rectangles. I agree with one of the things he said, but I don't agree with the other thing he said. What do you think I agree with? Ansley?
The triangle.
The triangles are identical because it told us that, right? But can we assume that our rectangles are the same? We cannot. All right, so they all are rectangles. We'll go with that, but we can't necessarily say that they are the same because we have to check the measurements. Well, we don't know that yet. We have to figure it out. Okay, so we don't know if the middle one is the same. The outside look like it's going to be the same, but we're not sure about the middle. What else do you guys notice about this shape? Like, you have to speak up, baby. The top triangle has what? What is that line usually, like with the way it is and everything, what do you think that line's representing?
Height.
That is your height. Okay, so this line right here, if you want to make it a different color, so, and I would do little dashes because that's what we're used to seeing, and I'd put my little 90-degree box if I could actually draw a straight line. That is our height. That is how we know that this is our height. Now, I don't have that same information in my bottom triangle. Do I need to have the same information in my bottom triangle?
No.
Raise your hand and tell me why. I know I feel like a broken record right now, but I need you to understand, Drake.
Because if we solve the top triangle,
Right. So when we solve the top triangle, we're going to get the answer for the bottom triangle, and we're going to add those two together. All right. Now, this is where triangular prisms are hard. Because we have the information on the outside, but I don't have information on this outside. How do I know for sure that these two are the same? What do I have to visually be able to see? Alex?
they're both rectangles, and if you take a ruler,
If you what?
let's say you grab a ruler.
Nope. Don't use a ruler because you don't have options to have rulers on a test or anything. How do you know that those two rectangles are the same? What do you think? Exactly.
Basically, it's the same measurements as the top triangle to cut off, and the rectangle with the width, the 7 meters, that's the same on the other side.
Okay, so I have a question. This is my net that we're looking at. Obviously not exactly the same, but it'll work for the purpose. So we know that one side of my top rectangle is 7, right? Now, you have to visually be able to say, okay, if I fold these two up, these two come together. So the slant of my triangle is 7 here, right? So then I have to say, okay, well, if I fold up the other side, what is the length of the slant of my other side of my rectangle? 7. All right, so whatever the right side is on your triangle, the left side is also going to be. There will be times, guys, when your triangles are equilateral. What is that going to mean? Equilateral triangles, what are those? All sides are the same. So then all sides, if that was an equilateral triangle, what would all the sides of a triangle be? Excuse me. What would all the sides of a triangle be? Answer. 7. All right. So lots of things to have to be able to see without actually being able to move it. So with that information, we know that this is 7, which means this is also going to be 7. Okay, so 2 of my rectangles are the same. And then what's the length of this side of my middle rectangle? What's the length? Kira? 15. All right, so I have all the information I need to solve this problem. So I'm going to label them again. My triangles. Do I have 2 of them? All right, so I'm going to put an A here and an A there. My outside rectangle goes with the other outside rectangle. And then my inside rectangle is all by itself. All right, so what is the formula to find the area of a triangle? What is the formula to find the area of a triangle? Ansley?
B times H divided by 2.
Yes.
1/2
Keep going.
times B times H.
Yes, you can use either one of them. If the base times height divided by 2 is easier or makes more sense, you can use that one. Okay, I'm not gonna like, as long as we're getting the same answer, that's what I care most about. So I'm gonna do 5 times, is it 6 or is it gonna be 7? 6, so 5 times 6, oops, equals what? What's 5 times 6? Gracie. All right, and then I'm actually going to divide it by 2. So, Gracie, what is my answer?
50 meters.
Did you say meters squared? Okay, so 15 meters squared. So both of my triangles are 15 meters squared. So can I just do 15 plus 15 and get 30 meters squared?
No.
Well, don't I have to? Because this triangle equals 15 and this triangle equals 15. So I'm just going to end up adding those 2 back together, right? So if you make the connection and say, well, technically I don't have to divide them by 2, and you understand that, fine. If you don't understand why, then just keep dividing by 2 and then multiplying it back by 2 or adding it. I don't care. All right, what are the 2 numbers for my outside rectangle? For B, what are my 2 numbers? What are the 2 numbers? Isaac?
15 times 7.
All right. Raise your hand and tell me what is 15 times 7? Drake?
105
Not just 105
meters.
meters squared. So this is 105 meters squared, and this is 105 meters squared. All right, and then C. What 2 numbers am I using for C? Okay. So 15 times 5. All right, raise your hand and tell me what is 15 times 5? Molly. 75 meters squared. All right. So I have 30 meters squared, I have 105 meters squared, and I have 75 meters squared. Do I have all the sides that I need to add? No, I do not. Why? Kira?
Because we didn't add we need to multiply 125 times 2 because of
So you can multiply this by 2 because they're both the same, or you can just add an extra one down here. All right, I don't care which way you do it, but stand up when you have your answer. Alright, so what is our final answer for our triangular prism? Samantha. So 315 meters squared. No matter how I solved it, that is what I should come up with. Thumbs up if that's what you got. Right? Which shape do you like better? Rectangular prism or triangular prism? Alright. So raise your hand if you like the rectangular prism better. Okay? Raise your hand if you like the triangular prism better. Yeah, y'all are crazy. Alright. So, at this moment, please do not glue this foldable in yet because I want you to be able to use it as you're going through today. Please get out the sheet of paper that I just passed out to you. And you need to title the top surface area practice. Now, this is where the red, green, and purple are going to come in, so please make sure you have those out. It is the 4th. Okay, I made one mistake. Just worry about everything else. Alright, so the directions say complete the chart by identifying the unique properties of each 3D shape. Use colored pencils to shade the various parts according to the directions. Now, if you're using a marker, I do not want you to necessarily shade the faces, because if you shade the faces, our ability to realize that we don't need to shade everything and then mess up all the colors, just don't try to go ahead, okay, if that makes sense. Just stay with me through this. It is going to be extremely important for you guys to understand this paper, because if you don't know how to identify what the shape is, how do you solve it? You can't. Alright, so the first shape. Raise your hand and tell me, what do you think that first shape is? And don't tell me it's a square, because it's not a square. Because squares are 2D shapes. We're dealing with all 3D shapes today. Drake. Yes, this is a cube. Alright. So, how many total faces do you think a cube has?
6.
Raise your hand. Samantha. It has 6 faces. Now, a base. This is where we have to be careful with our colors. And if you're using a marker, you need to be very, very careful. So, the base is the top and the bottom. Those are your bases. And we know this is a cube because all the faces are what? What are all of our faces? What are all of the faces? Squares. Ow. So first thing I'm going to do is underneath my 6, I'm going to actually write that they are all squares. Okay? Then you can pick any 2 squares for your bases. But we're going to pick the bottom one, and I just want you to lightly shade in the bottom one. And I want you to lightly shade in the top one. Do not color the entire thing in if you are using markers. Because if you color the whole thing in, it's going to be, you'll see why. So we have 2 faces that are squares for the base. Thumbs up when you're ready to move on. Alright, now, how many of you guys really struggled with the thing we did last week because you had no idea what a vertex was? 90% of you should have your hands raised. A vertex is a point where 2 things come together. So, how many points does our cube have? How many vertices does our cube have? Samantha? 8. All right, with your green, you're going to put a dot on each corner because that is a vertice. Okay, again, this should be neatly done, guys. You should not have giant blobs of green all over the place because you need to understand what each part of these are. So please make this as neat as possible. And then edges. How many edges do we have? And an edge is what? What is an edge? Gracie?
An angle.
No, that's the vertice. So what is an edge? What do you guys think? Oh, this is terrifying. Alex?
Like, right here below the rectangles.
Guys, just... No. Wait.
The 4 corners on the outside.
Huh?
The 4 corners on the outside.
No, those are vertices.
The outside of the words.
Use better words.
Outside, like the lines that are not dotted.
Those are not better words. It's where two faces come together. So it is the intersection. So like right here is an edge. This is an edge, right? Where these two pieces come together. That is an edge. This is an edge. Where this comes together. I just told you what it is. I don't know why your hand is raised.
There's a spider on the paper.
Where?
There's like a baby spider that crawled up.
Oh, I see him right there. He's hanging.
No, let it run.
No.
No. Flap him like little monkey.
All right, so we have 12 edges. So take your purple and you're going to... Thank you, Gracie. You get 10 extra credit points.
What?
I'm sorry, why are you speaking? All right, so now do you understand why I said being neat is going to be really important and not shading everything in and being sloppy? So that is the process for one of these, and I'm actually going to make my points a little bit bigger. All right, so the next shape, what is that? What is the next shape, do you think? What do you think the next shape is, Joshua? No, guys, rectangles are 2D shapes. Triangles are 2D shapes. Squares, 2D shapes. Parallelograms, trapezoids, those are all 2D shapes. Silas?
Rectangular prism.
Yes, this is a rectangular prism. So, how many faces do you think this has? It's very similar to a different shape that we just talked about. How many faces do you think this has? Summer, what do you think? Okay. And what do we think those shapes are? So these are the 2D shapes that make up this 3D shape. So what is this front shape? What is the back shape? What are the side shapes? Kira. Well, can a rectangle be a square? Yes. So they're technically all what? No. All rectangles. And again, guys, remember, you have this thing right here, right? All the information we're writing down here can be found in here, except for the pyramids. All right, so how many bases does this shape have? Again, look at the first row that we did. How many bases does this shape have? Sincere? 2. All right, raise your hand and tell me, what are the 2 shapes that make up my bases? Look at the name of this shape. Raise your hand. Drake? Yes. I just didn't want you to embarrass yourself. Say the wrong thing, Gabe. Huh? Alright, so you're going to go ahead and add a little bit of color to the top and to the bottom to identify your base. Now, how many vertices do you think this one has? I'll give you a hint. It's the exact same as what shape?
The cube.
The cube. So you should have 8 vertices and you should have 12 edges. Stand up when you have this done. All right. So now, the next shape is a 2-dimensional shape or is it a 3-dimensional shape? 3-dimensional. Everything shape-wise that we're talking about today that we're looking at in here is 3-dimensional. Now, the shapes that make up these shapes are what? 2-dimensional. I want to make sure you guys understand that. So, this cannot be a rectangular prism. This cannot be a cube. There's only one other thing we've talked about today that this can be. What is it? Isaac. All right, so this is a triangular prism. Yes, baby, it's right there. All right, so this is a triangular prism. How many faces make up this shape? So don't call it out. Please raise your hand. How many faces make up the shape? Stop playing with your markers and follow along now. And if you're not sure, you can use this. Flip to this one. You can count them there. You can count them here. Because all triangular prisms have the same number of faces. Everly.
5.
Okay, so there are 5 shapes that make up, or there are 5 faces that make up the shape. What are the 2 shapes? Raise your hand. What are the 2 shapes that make up this shape? Gabe, tell me one.
Triangle.
Okay.
And rectangle.
Shh, I said give me one, son. No. So triangle and rectangle. All right, what are the bases? Now be careful. The bases is what names the shape. So our cube, our base was a square, right? Top and bottom of a square. The rectangular prism was the top and bottom, which are both rectangles. So our triangular prism, what would our bases be here? What do you guys think? Blake. So just 2 triangles. Okay, and our 2 triangles, depending on how we're looking at our shape, but essentially for this one, it's this one and that one. All right, how many vertices do we have? So how many points do we have on this shape? So figure out your points and then raise your hand. How many points do we have? Christian. Yes. You have 6 points. So you have 3 on essentially the front and 3 on the back. And then how many edges do we have? How many edges do we have? BK.
9.
Yes. All right. The next two shapes we have not talked about. We are going to get into them, just not today, but I did want to obviously talk to you about pyramids. You will see two different pyramids. One is a square/rectangular pyramid. Again, it's named by its base. And one is a triangular pyramid, which are both of these. So this one is a rectangular pyramid. All right, how many faces does this shape have? How many faces does this shape have? Gabe? No. Kira? Huh? 5. So it has 5 faces, which you have triangles and then the rectangle on the bottom. All right. How many bases does it have? How many bases does it have? Silas? 1. And what is that shape? Rectangle. Okay. How many vertices does it have? So how many points does it have? How many points does it have? Silas H. You said 5? Yes. Okay. And then how many edges does it have? Raise your hand. How many edges does this have? Isaac.
9.
Not 9, because the height doesn't count.
Oh, okay. 8.
So it's got 8. All right, and the last one. So what kind of pyramid is this one? Look at the base. What kind of pyramid is this one? What kind of pyramid is this one? Looking at the base. Ansley.
Triangle.
So this is a triangular pyramid. Gabe, stop mumbling to yourself, please. All right, how many faces does this have? How many faces does this have? Molly. And what are all the faces? So it's got 4, and they will all be triangles. All right. How many bases does it have? Kira? 1. And what is the shape? How many vertices does it have? How many vertices? So how many points does this have? Silas? And how many edges does it have? Molly? 6. All right, stand up when you have this done. So the two questions on the bottom. The first one says, what do you notice about the difference between pyramids and prisms? So what is the biggest difference looking at the 5 shapes that we have on our page? So with prisms, what do you notice about all the prisms? They all have something in common. Samantha.
All the figures either have a rectangle or a square.
Okay, so we're gonna say rectangles because rectangles can be squares, squares cannot be rectangles. Okay, so prisms, stop banging your pencil, whatever it is on the table. Prisms have I cannot spell. Should be rectangular. So prisms have rectangular faces. And how many bases do all of our prisms have, no matter if it's a triangle, cube, or a rectangular prism? If y'all don't stop calling out, I'm going to give the entire class silent lunch today. Kira. 2 bases, yes. And 2 bases. Now, pyramids. What do we notice about pyramids? What do both pyramids have in common? Gracie.
They only have one.
Okay, so pyramids only have 1 base. And what else? What else do both of those pyramids have in common?
They both have triangles.
And triangular faces. All right, stand up when you're done. All right. The second question. I don't necessarily like it, but we're going to talk about it. So it says, Jonah says that a triangular prism is unique because it has 2 triangular faces. Do you agree or disagree? Now, before you answer and call out and make yourself sound silly, 2 triangular faces. What does a triangular prism have? No, I'm the last I checked and looked at my paper, there are only 2 faces on a triangular prism. And this is why I don't like this question. Because technically, yes, it does have 2 triangular faces, but what are those faces actually called? Look at your information on your triangular prism row. What are those faces actually called? Yes. So technically, you would disagree. And like I said, I don't necessarily like it, but, and you would write a triangular move it up a little. A triangular prism is unique because it has 2 triangular, and I want you to capitalize the word bases. So the only difference between what that person said and what we said is the name or the word face and base. Okay, that is why it is unique, because it's got 2 triangular bases, not just 2 faces that are triangles. stop messing with the little, whatever it is, Everly, stop. All right, you can glue this in when you are done. I would glue my foldable in as well so that you have it and it doesn't get lost. You guys are down to one more Fun Friday that is not happening. However, if you continue to talk, I will add more to your Fun Fridays that you're not having. Thumbs up if, or raise your hand if you still need this. Turn the page. And you need to title it Surface Area Homework. And then go ahead and glue the sheet that I just passed out to you into your notebook. Glue the whole thing down. And this is your homework tonight. Go ahead and get started on it. If you finish your homework before the end of class, I would go ahead and get back to work on Delta Math.